This is the new LDO superpower motor. Superpower? So yeah, Jason at LDO sent me 4 of those new motors, the superpower motors. And in this video, we're gonna try to find out if the name of it is good for those motors. Are they really superpower? We're gonna find out, but these are the new version. They are the successor of the well-known Speedy motors, the 48mm version NEMA 17 motor from LDO that we've been running on VZBot since day one. And many other printers are running the Speedy version. It's a great motor, very powerful. It had a lot of advantages. I love them. I've been running them. Those are great motors, but they were not perfect. Everybody knows that they were really noisy at certain speed, especially at 100 millimeters per second, around 50 millimeters per second. They were having a lot of vibrations, but with good tuning and once you know how to work with them, they were awesome motors. But this new version is supposed to fix some of the downsides of those Speedy. So we're going to try to find out if it has fixed those issues, if it's better, if it's not. We're going to test that. Unfortunately, I need to go on vacation in a week, so I'm leaving for a week of vacation, so I didn't have enough time to do a full comparison video between the Speedies and the Superpower. That might come once I'm back from vacation. It depends on if people wants to see that, but I thought I would do a quick video tonight just to show you a bit what I've experienced so far with them, and because I was so excited, I want to show that with you, even if it's not a full review or a full head-to-head comparison with the Speedies. So let's just first start by comparing the specs of the Superpower versus the Speedy, and you're gonna see the differences and where we are aiming with that. Then we do some tests, and we're gonna be able to see how they perform. Alright, we are looking at the datasheet for both motors. On the left you have the Speedy Power, on the right the Superpower. And unfortunately I don't have the torque curve for the Speedy motors, but I do have the one for the Superpower. And as you can see on that graph, the faster they spin, the better they get in terms of torque, which is crazy, and it's a bit different than what we were used to see, but I like seeing that curve because I like speed. So yeah, that is a good motor for me. Taking a look at the specs, on the left, let's start by the rated current. 2.5 amp per phase on the Speedy, 2.8 on the Superpower, which is quite a big increase in terms of current. But let's take a look at the resistance and inductance. 1.2 ohm and 1.5 millihenry on the Speedy, but 0.7 ohm and 0.6 millihenry on the Superpower. This is something I've never seen on a NEMA 17 so far. This is incredibly low, and that will allow a lot more current to flow through those coils, and that we can see that in the torque. The next stat, we lost a bit of holding torque, went from 5.5 on the Speedy but 4.2 on the Superpower. But let's take a look at the detent torque, the torque when it's actually running. 20 millinewton per meter on the Speedy, up to 25 on the Superpower. That is a big increase. That is a big increase, and I'm very happy to see that. And the last specs that I'd like to show you is the rotor inertia. It didn't change. 84.5 gram per centimeter square, and that didn't change on the Superpower. So what that means is, and I think, and correct me if I'm wrong, but I think this will relate into similar input shaping graph. Even though they are different power, it might be a little different, but I highly suspect that they will have similar input shaping because the mass moving inside at the same frequency will be exactly the same. So I suspect that it's going to be the same in terms of input shaping result. But we're going to be able to see that. We're going to test that. So on to the first test now. All right, we are ready for our first test. The first test I'm going to do is try to see how much acceleration we can get out of those motors. But this time, a little different. I'm going to do acceleration in the x-axis. So having all four motors working together. And for this, I have set up this little macro here. It will start the test at 2000 millimeters per second and 30K acceleration, and will crank up acceleration at every stop and go by 100. So it will go very quick, and it's gonna accelerate a lot. So I'll keep my finger ready on the emergency stop button, and we're gonna do it this way. If you want to reproduce this test at home, well, first of all, I don't recommend it. I would recommend only going at 1000 millimeters per second and do the diagonal test. So that way there's only two motors and you can test your real acceleration on the weakest point of your printer. But just for this one, I wanted to test the maximum power, maximum acceleration that we can get. So let's just do this, and we're going to keep an eye on the acceleration here at the bottom, and I'm gonna start the test right now and keep my finger very close to that stop button. So let's do this. All right, 45K, 50K, that's 60K, 70K, 80K, 90K, 100K, 110, 120, 130. Wow, 129. I think it stopped at 129. Ooh, wow. Just for reference, I was about maxing out at around 40K on the speedies. But granted, those tests were, the speedies were with the extruder. I mean, not the Goliath air-cooled. This is the Goliath water-cooled, shorter version. So I've probably removed like 10 grams on the print head. So that may impact performance on the older one. But I've also added water cooling. So I think in terms of weight, it's pretty much similar to what was there before. And I was maxing out around 40K, and now 129 at 2000 millimeters per second. Completely crazy. Jason, you're the man. Thanks for those motors. On to the next test now. All right, on to the second test. I'd like to see if we can reach 3000 millimeters per second. If we reach that, that would be totally insane. So it's a pretty short axis, and if we take a look at the math there, we have a travel length of 220. It's a 235 axis. I'm not going to use the entire axis just to avoid issues. Well, maybe we're going to do 230. So if we do 230, look at that. With 45K and going through 3000, we have a short amount of time, about like 25 millimeters of travel that will be at full speed. And we're going to try that. We need 45K to reach that speed. So let's just set the printer for that. Let's do 45K acceleration and 45K deceleration. We have a max speed of 3000. The printer is home. Let me bring the print head in the middle of Y. So G1, Y 110, F... So that's going to move about there. And we are ready to do that G1X 230 at 3000 should be F 180,000. So you ready? Let's try that. Oh, it was close to success. It was close. It failed a bit at decelerating. Let me home that axis again. Let's do the same test again, but just lower the speed just a bit. Let's do 170. That did it. 170. Let me just calculate that real quick. 170 170 divided by 60, that is 283 millimeters per second. We can probably do 175. Let's try that. We're going to go to X0 now. 1, 2, 3. That did it. That did it. That did it. That is 175 divided by 60. 2,916 millimeters per second. So we are really close. Why can't you do this? Please do it once. Do it once. I want to reach 3,000. Let's do it again. Come on, you can do it. It's really close. Very, very, very close. So I think, well, let's see. We're just gonna drop down to maybe 44K, and we still reach that speed. Not for long, but we still reach that speed. So let me home that x-axis. Let's go to 44K. 44K. Accel and deceleration. Oops, so let's do Accel as well. Oh, 44. All right. Let's do that same test again. You can do this. Very close again. Very close. Very close. All right. Well, I'm not going to push it further. 2,916 is very close. If I had a longer x-axis, it would probably be able to do it just fine. This is relatively short axis, so I need super high acceleration to do this, but totally crazy. I was not able to reach that with the speedies. This is way above the speedies. This is totally crazy. We are at 2.25 amp, 16 microstep. All right, next test now. All right, the third test I'd like to do is just simply move the printhead at the notorious speed that the speedies were having ultra high vibration and sound. So we know for sure that at 100 millimeters per second, they were super loud, super vibrating. And I expect those to be the same. So let's just do the first test at 100 millimeters per second. I don't know how well you can hear that on a camera, but I think they are a bit quieter than the speedies. Let's do that again. It's not bad. It's noisy, but not as bad as the speedies, I think. We're gonna have to do more in-depth tests with a sound catcher or whatever, a dB level meter, whatever. You know what I mean. So let's just crank it up to 6,500 and see if that will. That's much better. That's actually usable, I think. Yeah, that I would totally print at that speed. I don't think that's going to cause artifacts. And what about if we go to 500 and 500? Oh. Yeah, that's not bad. So I think if you stay away from, let's say, 90 to 100 and, well, 95 to 105 millimeters per second, you will be okay without any noise or vibration artifacts. The other speed that was bad was actually around 50. So let's try that. Yeah, that's about the same issues we have on these motors. Let's do that one more time. Yeah, I would very, very not print at 50 millimeters per second. That is very noisy, but not that bad, but still, it generates a lot of vibration. I can feel that. So let's just do 3,500. That's much better. Let's crank it up to maybe 36. Oh yeah, that's better. So maybe that's what, 60 millimeters per second? So I would say avoiding 50. Let's just do another test at 2500. Noisy. Let's crank it, or let's lower it down to 2000. Yeah. So at a very low speed, they are still very bad at noise and vibration. But when are you going to print at those speeds? Never ever. I normally do those little low speed when I do very, very, very small parts, and that needs to be very slow. But since they are very, very small, there's not a lot of travel in X and Y, so you don't get those bad vibration, and you don't really see those artifacts because it's so tiny, and it's a really tiny part. So I think those motors are still very good. If you keep them spinning faster, then they're pretty quiet. Let's do one last test at 7,000. That's very good. That is very, very good. And at 8, that's even better. That's even better. And what about 10,000? Yeah, that's good. So past 8,000 is where it is very quiet. And that is 133. So I would say above 110 millimeters per second, you will get very good performance. At 100, you start to have some issues, but again, at 100 millimeters per second, you don't normally print at that speed unless you have very small part, and those very small parts, you won't have long walls to see artifacts and, VFAs. So I don't think it's an issue. I think those will be performing very good. So now on to a real time in a real world printing test to see how they perform. Let's do that. So I did a couple tests with Input Shaper and the Accel row meter, and this is the results with the LDO Superpower. And this is my X, and honestly, I didn't see any real difference between the Speedies and the Superpowers. They both have very similar graph in terms of input shaping. I have this little spike on X that was something I've resolved since, but it was my water cooling fittings, the little push fit there. They need to be secure. They were vibrating a bit, so that's fixed. But it's a pretty decent graph, and looking at the recommended acceleration, that's kind of crazy. Let's see the Y now. Same thing, that's a very clean graph and very good result. So let's just launch a print and see how that prints. There we go. We are printing with the Superpower. And I've used a super bright ASA color, and we are printing at 300 millimeters per second. And we are set at 20K acceleration. And that is so quiet. I don't know how the camera will pick that up. I've used my mobile this time because I tried to do this video with my DSLR and I couldn't get this quality of sharpness. And I'm zoomed in right now, and as you can see, and when I zoom in this camera, I forgot to turn off that feature, but it boosts the sound when you zoom in. But that is very, very quiet. I'm printing a Steppy from LDO, and it's printing very good. My first impression on printing with those motors is very good. It's a lot quieter than what it was with the Speedy, and I like what I see so far. That is a good speed. That is a very good speed, and it's super quiet in the room. Let's slow that down. So we're gonna do 50%, which means 150 millimeters per second. Listen to that. Listen to that, guys. That is very, very good. Very quiet. Awesome. Let's go back to 300 millimeters per second. And still very good. And printing quality, I don't know if the camera's picking that up, but I don't see any artifacts. I don't see any ringing. I don't see any bad quality. It looks very good so far. Oops, focus. All right, so it's slowly printing. Well, not slowly. It's printing it fast. Let's bump the speed. Let's bump that speed. 150, which is gonna be 450 on the straight lines. 20K. Again, can you hear that? That is freaking quiet. $450 millimeters per second. 20K. And it prints so good. All right, let's try to crank it more. I don't know, maybe I'm gonna have to crank temperature. I'm at 255, sorry. Let's do 175, which should bring us at 5 and 25. And even at that speed, they are still ultra quiet. Can I zoom more? It still sprint very good. I don't hear any weird vibrations. I don't hear anything bad. And we are at 525 millimeters per second. You guys want to see more? Let's do 200%, which should be... Oh, it's doing the top fill now. But we should reach 600 millimeters per second. Now listen. That is amazing. I'm super happy. Alright, I think that's enough. I'm just gonna let it run through the end. I'm gonna fast forward and show you the end result. Or maybe, well, it shouldn't take much to finish at that speed. Yes. I love those motors. Jason, thank you so much. Just be prepared. Make a lot of those motors. We're gonna need them. A lot of people's gonna need them. We're gonna put those on the official VZ bots. Because I just love them. They print good. It's a good improvement over the Speedies. Let's zoom a bit more again. Considering at the speed where that cube was printed, or that LDO Steppy, by the way, it's 150% scaled compared to the original model. And I've just noticed on the round circles, I get a tiny bit of vibration at 600 millimeters per second. But let me just crank the corner speed. 15 now instead of 10. That should fly a bit more. Oh yeah, that sound is gone now. Oh, that prints now. Let me, since we're using 20K, we should be around 20 square corner velocity. Let me set that to 20. And acceleration is down to 10K now on the top fill. But there we go. The outside wall should be very fast. Woo. They are quiet, man. I love those motors. It's almost done. There's a bit of quality issues on the print. I didn't use the fan, the cooling, and I've played with the speed. So throughout the print, the speed was changing, which also means that you can see where I've changed the speed exactly. You can see right here is where I've changed the speed. That's amazing. I'm happy, and the print is done. Let's see if we can take a closer look. Smooth layers. I don't see. Oh, come on. Yeah, there we go. Focus. Stay there, please. So that was it. I'm very happy with the test so far. And I'm going to play more with those motors. There's more tuning that might be needed. But so far, so good. Alright, that was it for my test for tonight. Do those motors deserve the name of superpower? I think so, yes, I think so. They have proven to be a lot of power. They have, yeah, lots of acceleration and top speed. And they are quieter. They are better, I think, in every aspect over the Speedy. Are they a lot better? I'm not too sure yet. I think they are better. To what point? For now, I think they're just better. I didn't have time to do more tests. I'm sorry. I'm going on vacation next week. So maybe more tests when I'm back. But for now, I'm really happy with those. And I think people are going to love those motors. So I think, Jason, you're going to have to produce them in mass production because we're going to need more motors like these. I'm thinking we should put these on the official VZBot kits because so far I love them. But I'm going to do more tests as time permits. I'm going to print more with them. But so far, I'm very happy. They are amazing. So thank you again for sending me those for me to test. I really appreciate that. And on this, folks, I hope you appreciated that video. And I'm pretty sure you're very anxious and you want those motors as well. Let's give LDO some time to produce them, and I'm sure we're going to see them on the market pretty soon. On this, I will see you again after my vacation in Jamaica. I'm bringing my family for a much needed vacation. I've been beating myself recently with just work, so we'll regenerate our batteries there, and we'll see you again in March. Have a good night, everyone. Thanks for watching. Goodbye.